Hey, college algebra. So today we're going to go over linear models. And linear models model geometric objects. So they are equations that model a straight line. And these straight lines have a slope and a y-intercept. Now, what is a slope? A slope measures the change in vertical versus horizontal, right? So basically it's just a ratio of the vertical to the horizontal. And so we use the letter M to designate slope. And again, it is the vertical divided by the horizontal. Like so. Or, as you may have heard it elsewhere, vertical being the rise, and the horizontal being the run. So rise over run. Now, what is the rise? That's the change in y. So we have a 1 point, y2, minus another point, y1. And then the run, it's the change in the x points, x2 minus x1. And this change, we use the triangle symbol here, delta. It's the name of that Greek letter, lowercase Greek d. And that's it. That's the slope. Slope is rise over run. That's the change in y over change in x. Now, it is important to note that if the slope is negative, then the slope is going down, right? As we move to the right, we're dropping down. If the slope is positive, then the slope is going up, right? As it moves to the right, you are going up the hill, not down this hill. And of course, if the slope is 0, you're just moving along a flat plane, right? You're not going up, you're not going down. Again, so if m is less than 0, that is negative. It could be something like this. If there is no slope, it's just straight across. And if it's greater than 0, then we're shooting up, just like that. Right? That's it. So let's talk a little bit about the y-intercept. The y-intercept is the point where x equals 0, and is where the line touches the y-axis, right? Hence the name y-intercept. So right here in this example, the y-intercept is right here. The y-intercept is 1. And for our linear models, they always look like this. We say y equals the slope times the x variable plus the y-intercept, which we typically denote with the letter b. And so note what happens. Right? Y is a function of x, so as you see right here. And so when we have f of 0, well, that's m times 0 plus b, giving us b, right? The b being the y-intercept. Very good. Okay. And again, slope is the rise over the run. Just like that. And note that in this example, b equals 1. So we're going to use this for the following examples. What is the equation of a straight line with a slope of 3 that passes through the point 1, 2? So we're given the point 1, 2. So let's plot that on here. And we're given that the slope is 3. So that means that our rise over run is 3 divided by 1, right? We've got our rise over our run. So the rise is 3, the run is 2. So you run over 1, and you rise up 3. So we have 2 points for our line right here. And let's see, 1, 2, 3, and down, okay? Note how the slope, if I go to the left, I drop down 3. If I move to the right, I move up. And so, trying to get that as straight as I can. There we are. And we can see that we've got a y-intercept of -1 already, just from the graph. But let's do this algebraically, not just by graphing. Again, y equals mx plus b. And so we already know the slope. And we do know the y-intercept from the graph, but we're going to pretend that we don't. We look at the point 1, 2, because that's the point that's given. So at 1, 2, where y is 2, x is 1, solving for b, we find that b equals -1. All right. Putting all this together, y equals 3x minus 1. Just like that. So first you use the fact the fact that the slope is 3, plug that into the equation, y equals mx plus b, and then you pick a point that's known, that was given, 1, 2, and so y is 2, x is 1. Maybe we put a little parentheses there. And solve for b, which we found to be -1. Plug that into the original equation, or right here, and there we are. We've got y equals 3x minus 1. Next example. Find the equation of a straight line passing through the point 2, 3, and 4, 5. So before we were given a slope and a point. Now we're just given 2 points, 2, 3, and 4, 5. So the first point, 2, 3, is here. And then 4, 5, that is up here. All right, so just keep that as straight as we can. There's our line. Now we got to find our slope. And our slope, again, that's rise over run. Which is delta y over delta x, which is y2 minus y1 over x2 minus x1. All right, so our change in y, that's 5 and 3. And our change in x, that's 4 and 2. Just like that. All right, so 5 minus 3 is 2. 4 minus 2 is 2. Telling us that our slope is just 1. And so we go back to y equals mx plus b. Knowing that m is 1 tells us that y is simply x plus b. Now here we do the same trick. We use a point. Note that we can either use 2, 3, or we can use 4, 5. It does not matter which point you use. We're just going to use 2, 3 since it involves smaller numbers. Those are a little bit easier to work with. All right. Solving for b. We get 1 yet again. And so our function, right, y, which is the same as f of x in this case, is simply x plus 1. Okay, moving on. All right, so now we're going to talk about parallel slopes. Two lines are parallel if they have the same slope. So note that these two lines are parallel because they both have a slope of m, but they have different y-intercepts. So the y-intercepts I've got are just kind of generic, so we'll just go ahead and b1. We'll call that b2 for each one. All right, this is our line, L1. And here is our line, L2. All right, that's how it works. Doesn't matter what the slope is, as long as they're the same, these two lines will be parallel. Okay. And so shorthand way of writing this would be L1 is parallel to line 2. All right, so let's do a quick example with this. Find the equation of a line parallel to y equals 4x plus 2 and passes through the point 1, 2. So we're already given this line right here. And this is the line, 4x plus 2. You can see that the y-intercept is 2, 2. And if you go 1 over, you go up 4 units. And so we want another point, but this one passes through the point 1, 2. So what do we know about this second line? We know that it has a slope of 4 because it is parallel to this line. So y equals mx plus b becomes y equals 4 times x plus b. And we've got this point here, 1, 2. So we use that point. Like this. And then we solve for b. So 2 minus 4 gets us -2. And so the equation of this line is y equals 4x minus 2. Okay. So again, run over 1, go up 4, so we'd be about up there. But we're a little bit off the grid, so let's go the other way. So go down 4 and go to the left. Note that that matches up with our y-intercept here. And there's our graph for the second line. Oop, there we go. Just like so. Okay. Next, we talk about perpendicular slopes. Perpendicular slopes simply mean that, well, the lines intersect at 90 degrees. So two lines are perpendicular if they intersect at 90 degrees. Right, and you usually do the superscript circle for the degree symbol. And so if the slope, basically the slopes would be what's called the negative reciprocal. So note that the slope here is m, and the same number m in the other line gives us a slope of -1 divided by m. Right, that's what the slopes will be if they are perpendicular. And for shorthand, to show two lines are perpendicular, we just use this perpendicular symbol like so. And so we got one line coming through, and that would be our B1, and if line 2 is perpendicular, it might look something like that, with that being our B2. All right, so let's do an example of this. We got y equals 3x plus 2, and here is the line for that. And we're given a point 3, 1. Right, here's our pertinent information here. So the slope is 3, so the slope for our second line will simply be -1 divided by the slope of the first line. So -1/3 is going to be the new slope. And so our line, a model of our line will be y equals -1 divided by 3 times x plus b, just like that. And we are given the point 3, 1. And so we plug that in. 1 equals -1/3 times 3 plus b. So 3 over 3 is 1, negative. So we add 1 to both sides to find that b equals 2. All right, so that is our y-intercept of our line. So y equals -1/3 multiplied by x plus 2. Just like so. So you can see these two lines intersect at the same y-intercept, right? That's the only point they have in common. And our line, -1/3, so that means we, remember, rise over run, so we run over 3, but we don't rise up 1, we go down by 1, right? If it's negative, that means we're going down. So 1, 2, 3, go down 1. And there's our first point. And let's go ahead and get our other point here. And when we graph this, you can see that, yes, indeed, that is a 90-degree angle right there. All right. Well, that's linear models. Let's go on. I'll see you guys on the next one.